and thanks so much for clicking on this video. And welcome to Integral of Symmetry. Integral of symmetry is a new method in order to calculate any primitive of any function in any dimensional space. And in this fourth video, we are going to see another function, another identity function, z equal s ds y equal s to the square plus y to the square, which is our new identity function and had the following representation in our right-handed three-dimensional coordinate system and have the following shade, which is known as a paraboloid, and that paraboloid, that surface is representative of that function, identity function s squared plus y squared, and the volume under that surface is going to be representative of our primitive that we are looking for that identity function. And we know that that volume is exactly the middle of the volume of the cylinder that circumscribes it, just like this cylinder that we are going to draw it. It's going to be the cylinder which circumscribes the paraboloid. And this means, in the vocabulary of the integral of symmetry, that the symmetry of that identity function is 2, exactly 2. And in terms of math of integral of symmetry, we can say the following: integral of s squared plus y squared, which is our identity function, the circular expansion s y is going to be equal the volume of the cylinder, the volume of that cylinder, this cylinder, divided by the symmetry of that identity function. And we know already that this symmetry is 2, and the volume of that cylinder is going to be the base times the height. And the base that we see in this representation is going to be r. This is our s axis, our y axis, our z axis, and that radius is going to be r equal square root of s squared plus y squared. And our basis, which is the area of that circle, is going to be capital B equal pi times r to square. And the formula is going to be now the base, which is pi times r to square times the height, but the height is z. The height is z divided by 2. And we plug in the value of that r and the z, and we have pi times r squared, the square and the root square are gone, and we have s squared plus y squared times z, which is s squared plus y squared divided by 2. And finally, we have our primitive, which is pi times s squared plus y squared to the power 2 divided by 2. This is our primitive of that identity function in the circular expansion. Now, in this point, as we did in the previous video, we applied the hypothesis of the integral of symmetry that states that the symmetry of the new function, which is going to be the power of the identity function, this new function s squared plus y squared to the power m. The symmetry of that function, of that power of the identity function, increase the same quantity that the power increased. That is to say, in the integral of symmetry vocabulary, we said integral of s squared plus y squared to the power m the circular expansion s y is going to be the same volume of the cylinder that contain, that circumscribe the paraboloid, divided by the new symmetry S prime. And this new symmetry is going to be the former symmetry of the identity function, which is 2, plus the increment of the symmetry by the power, which is m from the increment is going to be from 1 to n, which is n minus 1. And in the numerator we have again b, capital B, times the height, which is again b is going to be the same pi times r squared, which is going to be again s squared plus y squared times a height, which is z again, divided by 2 minus 1. 2 minus 1 is 1, and we have m plus 1. So we have finally pi times s squared plus y squared times z, which is now s squared plus y squared to the power m, divided by m plus 1. So we had pi times s squared plus y squared to the power m plus 1, divided by m plus 1 plus some constant of integration. And this is our formula of the primitive of any power of this identity function in circular expansion. And in the next video, we are going to apply this formula in order to calculate volume of the surface of the equation that are difficult to do in the classical methodology of the multiple integral and the changes of coordinate system. With this methodology, we had nothing to do with that methodology of changing the coordinate system to rectangular to coordinate to polar coordinate system, neither with the multiple integral. Only that we had to do is plug in that primitive the limits of integration, which are the equation of the surface that envelop the volume that we are going to calculate. Thank you so much, and we will see you in the next video.